Hi students, this is Mrs. Gifford again, and I am here to talk to you about solving one-step equations. So after this lesson, you'll have a very good review about how to solve one-step equations using inverse operations. Inverse operations just means how do we undo one operation with another one. So let's just get right into the examples and we'll go from there. So looking at example number 1 here, let me do this. Sorry about that. So in example number 1, we're going to solve for the indicated variable. And our first equation is x plus -4 equals -10. And then the second question is 18 equals y minus 7. And in each case, we're going to solve for the indicated variable. In the first equation, again, we have x plus a -4 equals -10. So the first thing that I'm going to do is just draw a line straight down to kind of just remind myself I'm going to keep everything on one side of this little red line or the other. And when we talk about inverse operations, we talk about what undoes an operation. So what's the opposite of adding? If you said subtraction, that's right. So we're going to do minus, and we're going to subtract whatever it is that's over here. So we're going to subtract a -4. And just like a triple beam balance in science or a teeter-totter, the rule is whatever we do to one side, we have to make sure that we do to the other side. So if I subtract, oops, not a -14. If I subtract a -4 from one side, I have to make sure that I subtract a -4 from the other side as well. So, oh, for Pete's sake. Let me make that a -4. Sorry about that. So I've got my red pen. I'm going to subtract this -4. So there's that. And now I'm going to draw a line just like when we learned how to add and subtract. We drew that line. And what do we know happens? Because I'm adding, I'm undoing this plus a -4. This cancels. And I'm going to bring my x straight down because that's what's left in my equation. And we already know that subtracting a negative is like adding a positive. And now I have -10 plus 4. And when you plug that in, it's like owing a friend $10. You gave them 4. You still owe them $6. So in this case, our solution is x equals -6. And then it's always a good idea to check your solution by plugging it back into the original equation. So I'm going to do that. I'm going to take that -6 and put it in place of my x. And then I'm going to think through what we know about integers. First of all, anytime we add two negative numbers, it stays as the negative. And we already know that 6 plus 4 is 10. So this does give us the answer that we want. I'm going to check that one off. Now let's take a look at this second example. It's very similar to that first one, letter A. And again, we just need to ask ourselves, how do we undo subtraction? The inverse operation from subtraction is addition. So I'm going to add 7 to both sides. Okay, again, we're going to keep it balanced. I'm going to show that work. I'm going to keep everything going straight down. And again, the 7's cancel. Anytime you have opposites, they become 0. We haven't done anything with the y yet. So that's going to come down, and I have my equals. And then 18 minus 7 is 11. So we would say our solution, you could either write it as 11 equals y, or you can rewrite it to be y equals 11. And again, I'm just going to plug it back into our original equation to check to see if this is really what we want it to be. Oh, where's my mistake, folks? Oh my goodness, sorry about that. So how many of you noticed, real quick, that I added... Oh, let me change my pen here. I added 7 here, but look what I did on this side. I subtracted 7. So, here's where you see, shoot, I shouldn't have erased that. Let me show you how I knew it was going to be a problem. So this was 18, right? So 11 minus 7 is 4, and I know that 18 is not equal to 4. So once we plug that in, and I think to myself, something's wrong, that's where I found out this mistake. So I'm going to rewrite that problem. 18 equals y minus 7. And again, I'm going to draw that line. How do we undo it? We add 7, and we add 7 to both sides. So there's 25 equals y. And again, I'm going to check that solution put that 25 right here, and I know that 25 minus 7 is 18. So again, y equals 25 is our solution, not 11. All right, last two examples, and then we'll get you on your way and for you to write your summary. So just like the first two, we're going to solve for each of these for the indicated variable, and our first equation is negative 15 equals 1/3 p, and we know that when a number is next to a letter, it means to what? It means to multiply. And how do we undo multiplication? It's division, right? So I am going to divide both sides of my equation by 1/3. And notice again, I drew that line down the middle, and I'm going to divide both sides by 1/3. Now I'm just going to grab my calculator here real quick, and I'm going to plug that in. Again, to enter that, I'm obviously going to turn my calculator on, and I'm going to do a negative 15 divided by, and anytime we want to enter any fraction into our calculator, we're going to put parentheses, and then I'm going to do 1 divided by 3, and I'm going to close it off with another parentheses, and then I'm going to hit equals. So this does equal negative 45. If you're thinking to yourself, how come that isn't negative 5? It's because the rule for dividing by a fraction is actually the same thing as multiplying by its reciprocal. So negative 45 is my answer, and I'm going to plug that back in just to see if what we've done is correct. And again, here's my negative 45. So I'm going to grab my calculator again, and I'm going to look to see if this 1/3 times negative 45 is what I need. So again, I'm going to put parentheses, 1 divided by 3 for my fraction. And I'm going to hit times, and again, I need this negative sign, 45 enters. And that does give us this negative 15. So we know that negative 45 is the solution. Last example. Let me get that green circle out of the way a little bit. So our last example is negative z over 7 equals negative 4. And again, the inverse operation, well, first of all, this fraction bar means division, so the inverse operation of division is multiplication. So I'm going to draw parentheses, and I'm going to put my negative 7 here, and times. I'm going to draw parentheses and put my negative 7 here. I guess I'll put parentheses around the negative 7 also. Draw my lines, and then negative 7 and negative 7 cancel each other out, so it does leave us with z equals a negative times a negative is a positive, and we have 28. Again, if you want to use the calculator, you can do negative 4 times negative 7 and hit enter, and there's your 28. So let's just check the solution. We're going to check to see if the opposite of, or negative, z over 7, does it really equal negative 4? Okay, I'm going to check that out. I'm going to hit clear, and I'm going to, whoops, I should have put 28, should have gone right there. And also, anytime you have this negative sign in front of a fraction bar like that, it can go either with the numerator or the denominator, so I'm just going to pick for it to go with the numerator. So I have negative 28 divided by 7. I'm going to hit enter, and it does equal negative 4, so we know that we've done this one correctly. So there's our 4 examples using inverse operations and solving one-step equations. And yes, we would like you to show your work with each of the steps, even with the problems that are super easy to do, because the more you can reinforce the skills with solving equations, the easier it'll be when we get into more challenging equations and or with equations that have larger numbers and not as easy to use. So here's our summary. Again, what's the main focus of the lesson? What did you learn? Come up with your own example, and then come up with some sort of a question. So there you have solving one-step equations, folks.